Hello, my name is Paul Quiava and I'm an aerospace engineering major from the class of 2017. Today I'll be solving a unit analysis problem, specifically problem number 8 in chapter 1 of the chemistry workbook. Problem number 8 asks, given that there are 1,609 meters in a mile, calculate the speed of light in a vacuum in miles per microsecond. Now before we start, we need to know the speed of light. This is something you'll pick up in physics, but if you haven't yet, it's really simple. The speed of light in a vacuum is 3.00 times 10 to the 9th meters per second. So how on earth do we convert this to miles per microsecond? Well, we're given that there are 1,609 meters in a mile, but your professor might not be this nice. You could just memorize the conversion, but if, like me, you hate memorizing stuff, there's just one conversion you can memorize that will get you from any imperial unit of distance to any metric unit of distance. And that conversion is 1 inch is equal to 2.54 centimeters. We can rewrite this in a more useful form, 1 inch per 2.54 centimeters. Converting this to meters per mile is a good primer in unit analysis. Before we start, the most important part of doing unit analysis is to always write down your units at each and every step. No matter what major you're in, even if you aren't doing a unit analysis problem, writing down your units is guaranteed to save your bacon one day. If you're unsure whether you're doing a problem correctly, units are a great litmus test. If the final units don't work out, there's probably something wrong with your work. But you can only perform this check if you write down your units every step of the way. So with that, let's get started. We know that there are 100 centimeters in 1 meter, and we know that in 1 foot there are 12 inches. Finally, we know that in 1 mile there are 5,280 feet. As you can see, there's plenty we can cancel. Centimeters cancel out, inches cancel out, and meters cancel out. If we run the numbers, we get that this is equal to 0.0006213711922, but that number is useless, for 2 reasons. 1, there are no units. From our unit analysis, we can see that the only units left are miles per meter. Or we can invert this for a more useful number, 1,609.344 miles per meter. But we're still not done. The second reason this number is useless is due to significant figures. I'm not going to cover all the rules about significant figures in this video. All you need to know is that when multiplying, the least number of significant figures takes precedence. Breaking this down, we know each of these conversions exactly to an infinite number of significant figures. So in this case, we can write down everything our calculator spits out, but this hardly ever happens. In reality, we do not ever know any measurements we take to an infinite number of significant figures. On a homework or a test, you must always keep track of sig figs. Good. With that out of the way, we can start on the problem. The speed of light in a vacuum is 3.00 times 10 to the 9th meters per second. To get microseconds down below, we multiply by 1 times 10 to the minus 6 seconds per 1 microsecond. This is something you should know from your metric prefixes. Now we need to get miles up top, so we use the conversion either that we were given or that we calculated. Meters cancel and seconds cancel. Punching this into our calculator, we get 1.8645219 miles per microsecond. But we're forgetting our significant figures. We know the speed of light to 3 significant figures. By definition, we know microseconds to an infinite number of significant figures. Finally, miles to meters is given to us to 4 significant figures. The least number of significant figures here is 3, so we need to shorten our answer to 3 significant figures. Rounding off, we get a final answer of 1.87 miles per microsecond. As you can see, unit analysis is very handy. To us Americans, 3 times 10 to the 9th meters per second is meaningless. But if I told you that light travels nearly 2 miles in a microsecond, you know that's fast. So, in summary, always write down your units, always round to the least number of significant figures, know your metric prefixes, and finally, it's useful to memorize a handful of conversion factors. Add these 4 tips together and you'll be a unit analysis expert in no time.